Hello, this is Mrs. Huntley. This is Module 4, Lesson 12, Linear Equations in Two Variables. Your essential question, how can I find solutions to linear equations in two variables? You should be on page 97 of your student workbook. Again, your EQ, how do I find solutions to linear equations in two variables? So our opening. It's an activity that I'm going to ask you to do. Emily tells you that she scored 32 points in a basketball game with only 2-pointers and 3-point baskets. So there were no free throws. So how many of each type of basket did she score? Use the table below to organize your work. So she scored a total of 32 points. How many possible 2-pointers could she have, and how many possible 3-pointers could she have? So go ahead and pause the video. So you're just starting, and I'm going to ask you to pause it and see if you can work out how many of each basket she could possibly have. Okay, so what did you come up with? So let's take a look at this here. And if she scored only 2-point shots, she scored a total of 32. So she didn't do any 3-pointers. She just did all 2-pointers. She would have 16 shots, right? And she'd have 0 3-pointers. Now thinking about the 3-pointers, if she scored a total of 32 shots, she would have to have had an even number of 3-point shots. If she had one 3-point shot, that means that she couldn't, it wouldn't add up to 32. It would no longer be an even number. So here's one thing to note. You can't have an odd number of 3-pointers in this problem because the total score given is an even number. So I know she's going to have at least 2 3-pointers, and if she has 2 3-pointers at 6 points, that means she can have 13 2-pointers. So again, I know she can't have an odd number of 3-pointers, so our next possibility would be if she had 4 3-pointers, she'd be able to have 10 2-pointers. If she had 6 3-pointers, she could have 7 2-pointers. And then if she had 8 3-pointers, she could have 4. And then finally 10 and 1. Hopefully, the way I organize my data, yours may not be in order like this, and that's okay. I organize my data to kind of be in order, and I logicked through it. In other words, I thought about 32, and I thought about if I divide 32 in half, I'll have 16, so that means the maximum number of 2-pointers that Emily could have had was 16, and that means she didn't score any 3-pointers. And then, again, I knew that she couldn't have an odd number of 3-pointers because that would give me an odd total at the end. So I just went up by even numbers of my 3-pointers, and I was able to then back into the number of 2-pointers she had. So if I'm looking at this as as having two variables, two things that I did not know, and I just kind of made it up as I was going, I kind of a guess and check filling that out. Now I want to write an equation. X is the number of 2-pointers and Y is the number of 3-pointers, and I can write some kind of an equation to represent the total points. I know the total points, they're giving it to me, 32, so I know it's going to equal 32, whatever I come up with. So 2-pointers, the number that I have to multiply by the X is going to be 2, because that's how much credit I get for dunking a basket with 2 points. So it makes sense that the next one is going to be 3y. So 2x plus 3y equals 32. And again, if I plug in any of these numbers, it's going to be a solution for the two-variable equation. So a linear equation in two variables, what is that? That's what we've been working with. It is an equation that has two unknowns, two things that we do not know about the equation. So in this example, we have the number of 2-pointers and the number of 3-pointers. Those are our two unknowns. When we add them together, they equal the total of 32. Standard form. An equation is in standard form when we say ax plus by equals c, where a, b, and c are constants and at least one of them is not 0. And right now you're going, huh? This equation up here with Emily is in standard form. And my pen is not working. This is standard form. This is our A, 2, x plus 3 is our B, equals C is our 32. So that particular equation is in standard form. Now, yesterday when you were working and I kept telling you we want our x to, or we want our y to be by itself on one side of the equal sign. That's something else. That's called slope-intercept form or y-intercept form. That's something else that we're going to be working with in future lessons. But right now, we're going to be looking throughout lesson 12, we're going to be looking at equations in standard form and figuring out how to solve them. Constants. Constants are known numbers. Variables are unknown numbers. So let's talk about what a solution is to our linear equation. Solutions are values for the variables that make the equation true. There are a number of different points that I want you to know about solutions. Number one, in a two-variable equation, there will be a value for both variables that will make the equation true. We write the solution as an ordered pair. Remember when we were writing ordered pairs and we'd have the parentheses and we'd have our x and our y. Like that. When we substitute the values for the x and the y into the equation, it makes the equation true if it is a solution. Now, if it's not a solution, when you substitute them into the equation, it will make the equation not true. That's how you would know whether it is a solution or not. And then I'm guessing you know and understand number 4 well. We can graph the solutions on a coordinate plane. And we've been doing that and we will continue doing that. So if you need to pause the video to make sure that you have all the notes, as always, you can put the notes in your own words, but just make sure that you've hit all of the points that I'm talking about here. And when you're ready, go ahead and turn the page. Page 99. The next thing is an exploratory challenge. It says find 5 solutions for the linear equation x plus y equals 3 and plot the solutions as points on the coordinate plane. So what I want to tell you right now is 0 is your friend. It's a really good number and it makes things easier. I always start this type of a thing by setting one or the other variable to 0 and solving the other one. So if we do that here and we set x equal to 0 and I write the equation 0 plus y equals 3, I can solve this and subtract 0 from both sides, whatever. Y is going to be 3. Makes it kind of easy. If I am graphing this, I know my x and my y axes. So x is 0, I don't go right or left, and I go up 3. 1, 2, 3. Now I'm going to do the same thing with my y. I can set y equal to 0 and solve for x. So x plus 0 equals 3. And hey, what do you know? X is also going to be 3. So I don't move upward, or I move to the right 3, and then I don't move up or down at all. So I've got my y-intercept and my x-intercept. Yes, these are words that, that you're going to need to know, your x-intercept and your y-intercept. Your y-intercept is where the point is on the y-axis. The x-intercept, you guessed it, where the point is on the x-intercept. Now, what I would tend to do is stick with numbers that are easy because I like easy math. I just, I really want to not have to think too hard with the mathematics that I'm doing. So I'm going to set x equal to 1. 1 plus y equals 3. And if I subtract 1 from both sides, I know that y is going to be 2. So I'll come over to 1, go up 2, and there's that point. I can do the same thing with y. I can set y equal to 1 and see what I get. So x plus 1 equals 3. It's going to be 2. So come over to 2, up 1. There we go. The next thing I'm going to do, well, let's see, the next lowest number, I'm going to set x equal to 4. And 4 plus y, excuse me, equals 3. So I need to subtract 4 from both sides, and y is going to equal -1. So come over to 4 and go down 1, and there's my next point. Now, are these the only possible solutions? No. it's just, that's kind of how my brain works, is I go with kind of easier numbers to start. I always set my x equal to 0, solve for y, set my y equal to 0, solve for x, get my intercepts in there, get a couple of other points. And then I'm going to look at this and I'm going to know, or I can make the conclusion that it appears that all of the solutions to this linear equation are forming a straight line. I did talk about y-intercept and x-intercept, so I want you to make a note. The y-intercept is the point on the y-axis, and the x-intercept is the point on the x-axis. The intercept, think about an intersection. Where is the point intersecting the x-axis or the y-axis? Okay. And when you're ready, turn the page. Page 100. Whoop, whoop. Okay. Find 5 solutions for the linear equation 2x minus y equals 10, and then plot the solutions as points on the coordinate plane. So I'm going to do my standard. I'm going to set x equal to 0 to start off. So 2 times 0 minus y equals 10. So then I'm going to have minus y equals 10. But I don't really want negative y. I want positive y. So I'll divide both sides by negative 1. And I'll have y equals positive 10, or I'm sorry, negative 10. So when I plot this, I'm going to start at 0, 0. I always start in the middle and go down 10. I can't really read these numbers, so I'm just going to count the lines. Here's 0, negative 10. So my y-intercept here is going to be at 0, negative 10. That's where it's crossing the y-axis. Now you might think that right now I'm going to set my y equal to 0 and solve for x. And I can do that. However, because my x variable is being multiplied by 2, it's a lot easier to set my x's, do that multiplication, and just solve for y, because y is all by itself right now. So I'm going to continue just fixing my x's and solving for y. So again, I'm going to stick with easy math. 2 times 1 minus y equals 10. 2 times 1 is 2. Minus y equals 10. Subtract 2 from both sides. And negative y is going to equal 8. So if negative y equals 8, positive y would equal negative 8. And again, I can plot that on my graph. And I'm going to go with 2. Right now, if you'd like to pause the video and figure the rest out on your own, you can feel free to go ahead and do that. You might be seeing a pattern. If you're not already seeing a pattern, I would see if you can figure out the pattern as you're working through it. Okay, so here is the rest of my work. So as you can see, I stayed with the same pattern where I was just increasing my x values by 1 each time and doing the math. And if you notice, so this is going up by plus 1 each time, and this is going up by plus 2 each time. So my change in my y values is going up by 2. My change in my x values is going up by 1. So without doing any math, if this goes up to 5, what are we going to expect to happen here? Yep, it's going to go up by 2, and it would be 0. When I'm plotting this on my graph, I'm also seeing a pattern with where my points are falling. So the first one was at 0, negative 10 down here. Then my next one was at 1, negative 8. And I said my y value is going up by 2. And if you look, I'm going up 2. And my x value is going up by 1. I go right 1. So I'm going up 2 and then right 1. So there's a pattern happening here on your graph as well as on your table, if you're being methodical as far as how you're plotting your numbers. So remember I said I was fixing my f, meaning, or my not my f, my x, excuse me, fixing my x value, which means I was choosing the x value and then solving for y. I could have chosen my y and solved for x also. I did this because there was a coefficient with my x, which makes it easier to do that multiplication and then get that term onto the other side of the equal sign, and then my y was basically by itself. I mean, it was negative, so I knew I had to flip my sign, but for the most part, I could solve this equation in one step after I did the multiplication. Let's look at how we pick whether we're going to fix x and solve for y, or fix y and solve for x. So our next example is an equation, which there's a little typo here, so you need to fix the typo. The equation is x plus 5y equals 21. So it's correct up here, but down here we have x plus y, or x plus 5, and that y is missing on both of these. So we need to fix that, or stick that in there. So if I begin doing things the way I normally do them and fix my x and solve for y, I'm going to put a 0 in here for x, and I'll have 0 plus 5y equals 21. So I'll have to solve that 5y equals 21, so that 5y equals 21, divide both sides by 5, divide by 5, and my x is, or my y is going to be 4 1/5, or 21/5. So, okay, well, that worked, and it wasn't that hard. So let's see what happens if I stay in the same kind of pattern that I've been doing. So I'm going to set this equal to 1, and then I'll have 1 plus 5y equals 21. I've got to subtract 1 from both sides, and I have 5y equals 20. Oh, I can do that division in my head, so I know my y here is going to be 4. So that was very helpful. Let's see, if I go up by 1 again, I'm trying to keep my math easy, remember? So 2 plus 5y equals 21. Subtract 2 from both sides. 5y equals 19. Ooh, 19 divided by 5, 19/5. So I've got 19/5. That's kind of ugly. That's about 3 4/5. I'm not finding this particularly easy, are you? What would make this easy? Maybe if I could figure out what number I need to take away from 21 to be divisible by 5, so I can get whole numbers for my y, that might make it easier. Let me think. If I take 6 away from 21, that's going to be 15, so that'll work. Let's try fixing x as a 6. So I'll have 6 plus 5y equals 21. Subtract 6, subtract 6. 5y equals 15. So I know my y here is going to be 3, because 15 divided by 5 is going to be 3. So that worked. Let's see. If I take 11 away from 21, it's going to be 10. So if I have 11 plus 5y equals 21, subtract 11, subtract 11, I'll have 5y equals 10, so I know this is going to be 2. That, frankly, took a lot of brain power for me to figure out what numbers are going to give me whole numbers for my y. So let's see if maybe it's easier to fix the y and solve for x. So let's start the way I normally do. Let's fix that equal to 0. X plus 5 times 0 equals 21. Ooh, that's easy. X equals 21. Cool. I like that. If y is 1, x plus 5 times 1 equals 21. 5 times 1 is 5. So I'm going to subtract 5 from both sides, and I'm going to get x equals 16. Pretty easy again. Okay, if y is 2, x plus 5 times 2 equals 21. X plus 10 equals 21. Subtract 10 from both sides, and I get 11. I'm liking this a lot more. Do you guys see when your variable has a coefficient with it? That's the one that's easier to fix. You're going to get whole numbers if you fix that one instead of the other one. So x plus 5 times 3 equals 21. X plus 15 equals 21. Subtract 15 from both sides, and x is 6. And finally 4. X plus 5 times 4 equals 21. This is 20. So subtract 20 from both sides and x equals 1. If you notice, we have some that are the same, and they should be the same. I've got a 1, 4 here and here, and I've got 6, 3. Once I figured out what I was doing on the other side, it worked. So which table was easier to complete? In my opinion, it was easier to complete the second one where you fix the variable that has the coefficient with it, and you can do the multiplication, and then you know exactly what you're subtracting from both sides. So in my opinion, that was the one that was easier to complete, and it was easier to complete because you're doing the multiplication at the same time and you're not worried about getting weird fraction numbers. Not incorrect either way, but again, in my opinion, one was easier than the other one. Looking at our graph, there's only 3 points that I came up with that are actually going to be on the graph. So we have 1, 4. So 1, 2, 3, 4. It's right there. And then we have 6, 3. And then we have 11, 2. And let's see if we can figure out the pattern that's happening in our graph here. We're going to get from one point to the other. Let's see what the difference is going up and down. Look, it's only 1. I'm going up 1, and then I'm going over 1, 2, 3, 4, 5. I'm going to the left 5. See if it works again. 1. So if I want to know the next point, I bet you I could figure it out. If I go up 1 and then over 1, 2, 3, 4, 5. Let's see, that would be negative 1, 2, 3, 4. So negative 4, positive 1, 2, 3, 4, 5. Negative 4, 5. Let's see if that might be a solution to the equation. So negative 4 plus 5 times 5 equals 21. So negative 4 plus 25 equals 21. It works. So that would be a solution as well. So I'm going to have a conjecture here that says if I keep this same pattern, again, if I go up 1 and then over to the left 5, 1, 2, 3, 4, 5, this would also be a solution. Okay, let's look at the next page real quick. Consider the linear equation. I know we're going kind of long, I'm sorry, but I just want to get through a couple of more things, and then I think we're going to be good to go and do this, this whole lesson in one video. So consider the equation 2/5 x plus y equals 11. Will you choose to fix values for the x or for the y? Which do you think is going to be easier? Okay, I would choose the x because, again, it has that 2/5 next to it, and I know if I choose values for the x, I can multiply that and possibly even remove that fraction so I don't have to deal with the fraction, and then I can solve for y pretty easily because the y is by itself. So I'm going to choose to fix x because I can solve, do the multiplication. Okay, so I kind of hinted to this. Are there specific numbers that will make my computational work easier? Because again, we like easy math. Yes, I can choose values for x that are multiples of the denominator. Why? Because if I multiply by multiples of the denominator, I will remove the fraction. So if I multiply, if my first value for x is 5, 2/5 times 5 plus y equals 11. 2/5 times 5 is going to be 2. 2 plus y equals 11. Whoops, that one didn't stay. So I'm going to subtract 2 from both sides, and I know my y value is going to be 9. So what looked like an intimidating, difficult problem really wasn't that difficult. So the next one I'm going to fix is going to be the 10, because 5 times 2 is 10. So 2/5 times 10 plus y equals 11. 2/5 times 10 is going to be 4. 2 times 10 is 20, divided by 5 is 4. Subtract 4 from both sides, and I know my y is going to be 7. So what I would like you to do is finish filling out that table. And once you have that table filled out, we are going to graph our results on the graph on the page, on the next page. If you notice, however, on this graph, there are no x or y axes. So what we need to do is draw them in. So take a straight edge or a ruler of some sort and draw in an x and a y. Now you can put it anywhere. What I would suggest is actually doing a couple of negative values. So maybe multiply, have one of your x values be a -5, and then you'll see how it actually works. So I'm going to draw my y-axis there and my x-axis here. And I'll actually plot the numbers that I already figured out. And again, 0, 0 is where your two axes meet. So the first one I did was 5, 9. So I'm going to go 5 over to the right. 1, 2, 3, 4, 5, and then 9 up. 2, 3, 4, 5, 6, 7, 8, 9. And that's my first point. The other one that I did for you was 10, 7. So go right 10 and then up 7. So there's my next point. So what I want you to do is finish the table and finish the graph before you come to class tomorrow. And that is going to conclude the video portion of this lesson. So some of the big ideas that you should have gotten out of this lesson: a two-variable linear equation that is in the form of ax plus by equals c is said to be in standard form. And a solution to a linear equation in two variables is an ordered pair. That's your parentheses with your x and your y that makes the equation true. Solutions can be found by fixing a number for x and solving for y, or by fixing the number for y and solving for x. Sometimes it's really easy, sometimes it's a little bit trickier. When one of your variables has a coefficient, that's the easier one to fix. And if there's a fraction, if you choose numbers that are multiples of that fraction, it does remove it, and it makes it easier to deal with whole numbers for your x and your y coordinates. So I hope you enjoyed this lesson. I do apologize that it went as long as it did, but instead of having it in 2 days, you have one lesson in 1 day. So there's no homework over the weekend. Whoop, whoop. Have a great day. See you tomorrow.